Okay, so good morning, everyone. So our topic for today is about building information system. So actually, at present, no, especially today, no, a computer science students, no, are actually allowed also to develop your own system, no. But most commonly, we are more focused on research as a computer science students. So after the discussion of this lesson, no, we will be able to answer the following questions. Now, number one, how does building new system produce organizational change? What are the core activities in the system development process? What are the principal methodologies for modeling and designing systems? What are the alternative methods for building information system? And what are new approaches for system building in the digital firm era? Now, building new system or new information system is one kind of planned organizational change. No? So the introduction of a new information system involves much more than new hardware and software. So it is also includes changes in jobs, skills, management, and organization. So when we design a new information system, we are redesigning the organization. So system builders must understand how a system will affect a specific business processes in the organization as a whole. Okay, so of course, the information technology can promote various degrees of organizational change, ranging from incremental, no, to far-reaching, no. Of course, the four kinds of structural organizational change that are enabled by information technology are automation, rationalization, business process design, paradigm shifts, no? And each carry different risk and rewards. Okay, to give us more details about the topic, let us all welcome our presenter.
Building information system. One type of planned organizational change is the creation of a new information system. The implementation of a new information system entails much more than the installation of new hardware and software. Information technology may help organizations evolve in a variety of ways, from little tweaks to major overhauls. System analysis, system designs, programming, testing, conversion, manufacturing, and maintenance are the primary tasks in systems development. System development and organizational change. Information technology can promote various degrees of an organizational change ranging from incremental to far-reaching. There are four kinds of structural organizational change that are enabled by information technology. Automation assists employees with performing their tasks more efficiently and effectively. Rationalization, a different form of organizational change and one that follows quickly from early automation. Business process redesign. Business process are analyzed, simplified, and redesigned. Paradigm shifts involves rethinking the nature of business and the nature of organization. Each carries different risks and rewards. Business process redesign. Business process management provides a variety of tools and methodologies to analyze existing process, design new processes, and optimize those processes. It has to go through the following step. Identify process for change. Managers need to determine what business processes are the most important and how improving these processes will help business performance. Analyze existing processes. Existing business process should be modeled and documented. Nothing inputs, outputs, resources, and the sequence of activities. Design the new process. When the existing process is mapped and measured in terms of time and cost, the process design team will try to improve the process by designing a new one. A new streamline to be process will be documented and modeled for comparison with the old process. Implement the new process. New information systems or enhancement to existing systems may have to be implemented to support the redesigned process. Continuous measurement. Once the process have been implemented and optimized, it needs to be continually measured because they may lose their effectiveness if the business experiences other change or deteriorate over time as employees pull back on old methods. Overview of systems development. The activities that go into producing an information system solution to an organizational problem or opportunity are called systems development. Systems development is a structured kind of problem solved with distinct activities such as analysis, system design, programming, testing, conversion, and production and maintenance. System analysis, the analysis of a problem that a firm tries to solve with an information system. It also includes of feasibility study to determine whether the solution is feasible or archeable from a financial, technical, and organizational standpoint. Establishing information requirements. It carefully defines the objectives of the new or modified system and develops a detailed description to the function that the new system must perform. Systems design shows how the system will fulfill this objective. The design of an information system is the overall plan or model for the system. The role of end users. Users must have sufficient control over the design process to ensure that the system reflects their business priorities and information needs, not the biases of the technical staff. Completing the system's development process. The remaining steps in the system development process translate the solution specification establishes during system analysis and design into a fully operational information system. They are programming, system specification that were prepared during the design stage are translated into software program code. Testing conducted thoroughly to ascertain whether the system produced the right result. Conversion, the process of changing from the old system to the new system. Production and maintenance, after the new system is installed and conversion is complete, the system is said to be in production. Change in hardware, software, documentation, or procedures to a production system to correct errors, meet new requirements, or improve processing efficiency are term maintenance. Modeling and designing system, structured and object-oriented methodologies. There are alternative methodologies for modeling and designing systems. Structured methodologies and object-oriented development are the most prominent. Structured methodologies. Structured methodologies have been used to document, analyze, and design information systems since the 1970s. It refers to the fact that techniques are step by step, with each step building on the previous one. They are top down, progressing from the highest, most abstract level to lowest level of detail. From the general to the specific process specification describe the transformation occurring within the lowest level of the data flow diagrams. They express logic for each process. The structure chart is a top-down chart showing each level of design, its relationship to other levels, and its place in the overall design structures. Object-oriented development. Object-oriented development addresses these issues. It uses the object at the basic unit of systems analysis and design. An object combines data and specific processes that operate on those data. Computer-aided software engineering. Computer-aided of software engineering is sometimes called computer aided systems engineering provides software tools to automate the methodologies we have just described to reduce the amount of repetitive work the developer needs to do. Case tools also facilitate the, the creation of clear documentation and coordination of team development efforts. Alternative systems building approaches. Traditional system life cycle. The system life is the oldest method for building information system. The life cycle methodology is a phased approach to building a system, dividing systems development into formal stages. The system life cycle is still used for building large complex systems that required a rigorous and formal requirements analysis, predefined specification, and tight controls over system building process. Prototyping. Prototyping consists of building an experimental system rapidly and inexpensively for end user to evaluate. The prototype is working version of an information system or part of the system, but it is meant to be only a preliminary model. Step in prototyping. Step 1. Identify the user's basic requirements. Step 2. Develop an initial prototype. Step 3. Use the prototype. Step 4. Revise and enhance the prototype. End user development. Sometimes of information system can be developed by end users with little or no formal assistance from technical specialists. This phenomenon is called end user development. A series of software tools categorized as fourth generation language make this possible. Fourth generation language are software tools that enable end users to create, report, or develop software applications with minimal or no technical assistance. Query languages are software tools that provide immediate, only online answers to requests for information that are not predefined. Application development for the digital firm. In the digital firm environment, organizations need to be able to add, change, and retire their technology capabilities very rapidly to respond to new opportunities. Companies are starting to use shorter, more informal development processes that provide fast solutions. Rapid application development. The term rapid application development is used to describe this process of creating workable system in a very short period of time. Can include the use of visual programming and other tools for building graphical user interface, iterative prototyping of key system elements, the automation of program code generation, and close teamwork among end users and information system specialists. Sometimes a technique called joint application design is used to accelerate the generation of information requirements and to develop the initial system design. Properly prepared and facilitated sessions can significantly speed up the design phase and involve user intense level. Agile development focuses on rapid delivery of working software by breaking a large project into a series of small sub-projects that are completed in short periods of time using iteration and continuous feedback, component-based development, and web service. To further expedite software creation, groups of objects have been assembled to provide software components for common functions as a graphical user interface or on ordering capability that can be combined to create large-scale business applications. This approach to software development is called component-based development, and it enables the system to be built by assembling and integrating existing software components. Web service can provide significant cost savings in system building while opening up new opportunities for collaboration with other companies. Yan lang po, sir.
Okay, so I just want to add additional inputs related to the topic.
Now we're going to start talking about, I believe this is chapter 13 in our text, on building information systems. So the last lecture was on the best practices around managing and operating an IT service, IT organization that delivers IT services and value. Now we're going to look at exactly what that looks like in one particular area, which is developing information systems. It's actually a really short lecture because most of the time is normally taken up with a particular activity that I'm moving into next week, where we're going to practice some of the foundational pieces of building an information system, or a process approach that we use a lot at OU. So let's just jump straight in. So a couple of things just to set the groundwork. The reason that you're building an information system in most cases is to support some kind of structural change within the organization. That can be in a number of areas, and they cross each other in their value and importance. We have organizational change, so perhaps there's a new thing the business is trying to accomplish, and so you develop an information system to support that new thing. Sometimes it is using, we're going to look at some systems development processes for how you get from idea to actual implementation. And we're going to also look at a few alternate approaches to how you develop an information system. That's the content for tonight. The idea of structural change, though, back to that first topic, is enabled by IT in several ways, or supported by information systems in several ways. And you see those 4 bullets there we're going to look at in a little more detail. But first of all, the idea of automation. And that's, simply just the most direct, obvious way is replacing a manual task. I think back to if we would have this discussion if we were having class live, but think back to our barbecue restaurant of the topic. And I believe we've actually even talked about this one already, of taking some manual tasks and automating them. So placing an order instead of writing down on a piece of paper the sandwich orders, perhaps the ability to enter that data electronically, from a list of things. So you always get it accurate and nobody has to decipher your handwriting. You're simply replacing a manual task with an automated approach and making it more efficient, in theory, making it more efficient. So that kind of structural change can be enabled by something as simple as automation. The next level up, though, is this idea of rationalization of procedures. It's kind of a fancy and full mouthful of terms, but what it simply means is standardizing the way things happen so that they happen consistently and in a way that is effective, more effective perhaps than it had been. So that first bullet there of streamlining SOP. SOP stands for standard operating procedures, and it's just a set of procedures that you do over and over. They're the standard operating procedures. So every time you make this particular barbecue sandwich, you put the bottom bun, and then you put the meat, and then you put the sauce. You don't put the sauce and then the meat. And you think, well, what difference does that make? Well, if you've looked at that process, you know it makes a difference, because later on, perhaps we grill the top surface of the bun, and so that keeps it from getting soggy. Whereas if you put the sauce on first, the bottom bun hasn't been toasted and it gets soggy. Or there are reasons that you've looked at for why you want to follow that operating procedure. Well, you can do some of that same kind of thing. That's by taking information systems to help standardize. If something is supposed to be done the same way over and over and over again in a particular area, perhaps you can simply just automate that, or you can take it and use information systems to make that more convenient. A couple of really important terms here that you may or may not have heard before that are really important in this particular area, and that is they're called quality initiatives. In many cases, there's Six Sigma is one of those, total quality management, or TQM. TQM is kind of I don't know, I don't necessarily hear that much anymore. But I do hear one that's actually not on that slide called Lean, Lean, as in making something that's fat, leaner. And that's the idea of taking stuff out to make it more efficient. A lean process is a process that's been examined and used in such a way as to make it faster and faster and faster. So I actually had the opportunity to take a lean certification course a couple of years ago, and the ideas are really interesting and innovative. It comes out of the manufacturing world, particularly the car manufacturing world. And if you think an example that is very typical that they use to help understand this part of it is, if you're on an assembly line and you're building a vehicle and somebody's observing your process. So a person is standing at this point in the assembly line. They have to walk 3 steps over this bin and get a part and walk back 3 steps and then put that piece onto the vehicle. Well, a lean approach to that process is going to ask, why is the part 3 steps away? Because in total, that requires 6 steps. Well, you might think, okay, that's just going to take 1 or 2 seconds. Well, that's true. It will only take 1 or 2 seconds. But if you lean out that 1 or 2 seconds and make it half a second to grab the part and place it on, over time, over a number of people and over a number of facilities, you can actually increase the quality as well as the time, the total time, turn time is what it's called, how fast you can turn a product out. And all those initiatives, Six Sigma and Lean in particular, are all about increasing the quality of something to make it better. That is information technology and information systems approach can help each of those areas. There's actually a whole sub world of the Lean IT and what that looks like. So that's another area that information systems can bring structural change, is through rationalizing procedures. We don't have time to go into too much of that detail. The third area there is business process redesign, and we've talked about business processes. It's basically taking rationalization of procedures and taking it to the next step. We've talked a lot about that one, so I'm not going to spend time on it. And the last one is paradigm shifts. Don't really hear the word paradigm shifts much anymore, but it was a big term back in the 80s at least. where you were talking about using information systems, or in that case, it wasn't necessarily information systems, but in our case it is, and using whatever innovation you were bringing to the table to completely change what this company did. So Netflix went from being a company that was about distributing DVDs to being a company that streams content. That would be a paradigm shift, and there are probably even bigger ones than that. But we'll look at a couple of things around those things. If you put those 4 approaches on a map, they kind of provide an interesting risk and reward graph to look at. If you think about the reward is the horizontal axis, and it's simply a relative measure of how much value you could potentially get out of that. Whereas the risk register on the vertical axis there is about, well, how risky is it to try that? And it's really a straightforward relationship. Automation is really easy to do, meaning it has a very low risk, but its return is relatively small compared to something else. Rationalization is a little harder to do, more risky. You risk disrupting the organization more, but it can bring you more value and return on the other side, the flip side. Then you keep moving up the stack. Redesign is much harder to do, more risky to the organization, higher risk of failure, but it can drastically change things in the organization. And then paradigm shifts are hugely risky. They can fail spectacularly, but when they work, they can be of extreme value to the organization. So it's just a little interesting map of how that works. All right, so when it comes time to actually developing an application or an information system, and I'm going to actually use those words interchangeably in this section. So often we talk about that building an application, or building a piece of software, or building a capability. I'm going to just use all that stuff together. And instead of purchasing something, we're talking about developing the capability inside of the organization. A process that is often used and is very typical is this one that I'm going to expand on in a future slide, of the idea of, first of all, you analyze the problem, then you design the solution, you program the solution. That's literally when the developers, that's typically they're software developers or application developers, they take the design and they go and do all the coding in whatever language they may be writing the software application in. Then they program it, then you test it, and then this final step is called conversion. It's typically you're taking data from an old way of doing it and putting it into a new way of doing it. It's called a step called conversion. You want to convert the data from the old to the new. It's typically a really important step. And then finally, we're in production and maintenance mode. You can actually see some of the concepts of ITIL layered across some of this. You see the design, that's a one-to-one correlation, but transition would really fall across programming and testing and conversion, and then operations would be the production and maintenance part of this development process. So just a very high-level overview of how you get something from an idea to a solution in the application development world. I'm actually going to skip this slide because we're going to come back to it in week 6 and when we do our activity. But the point that's just to consider at the very, very high level is not everything that goes into building a solution is technical. And you shouldn't be surprised by that, because there are organizational and there are management and there are technical considerations to any application or software or information system that you're developing. Okay, a couple of models that it's important, I think you know some terminology around, and that is, the first one is something called SDLC. That actually stands for Software Development Lifecycle. Software Development Lifecycle. And it is often also called a waterfall method. And that's because if you draw these out, if you're familiar with a term called Gantt charts, and that's a project management term that essentially lists a topic that has to be accomplished, or lists all the topics or all the tasks that have to be accomplished on one column, and then you draw start and stop lines across in a horizontal manner. And perhaps you might have one that starts here and the next one starts shifted over a little bit because it's dependent on this one. It actually creates a graphic or an image that looks like a waterfall, and that's why it's called a waterfall method. But the whole idea behind it is you get the entire big giant list of things and tasks that have to be accomplished, and then you map them out about how they sequence or work together. That is a development methodology that is the primary development methodology, but it's also one that's falling out of favor. And in large part, it's because the speed of business is moving much, much faster than it used to. Things have to happen fast. And the biggest drawback to SDLC is that it starts with this idea that you have a completed list of all the tasks that need to be accomplished. Well, what if you don't have a list of all the tasks? What if you have the first 10 and then the rest of them you kind of discover as you're going? Well, that really throws off a software development lifecycle approach, a waterfall approach. And so typically what we have seen is the idea of some other areas that have developed. Prototyping and Agile. Agile is one we're going to spend just a minute talking about, but prototyping is the idea of developing a prototype and then testing it, and then going back and forth and back and forth. It's very similar to Agile, so I want to spend the time talking about Agile. Agile methodologies are really interesting. They have a lot of great terminology, things like scrums and stand-up meetings, and I don't know, there's some other terms around Agile that I find that are just interesting terms. But the idea behind Agile is that you work in much, much smaller groupings. So you don't have to know all the tasks. You just have to know the first 3 tasks, or the first small number of tasks. And you go and work on those. And you bring them back to the customer then and say, here's what you asked for, here's what we developed the first little bit. Is this what you wanted? And they say yes or no. And if they say yes, then great, you've got the first step, and then they give you the next couple of steps. It's a much more agile, faster methodology for getting something in place. It has these ideas of stand-up meetings. So every morning, when you're in an agile project, you meet for just a few minutes. And so because it's such a short meeting, I've seen places that actually take the chairs out of the room. So you can't sit down, and therefore it gets this idea called a stand-up meeting. But it's a very short meeting. It basically asks 3 questions. What did we say we were going to do? Here's what did we actually do? And what are the impediments to us doing it? Moving forward on the next steps. And you just meet on those things very quickly. The whole idea behind the Agile methodology is to develop content or to develop capabilities, the application capabilities, faster and more repetitively in a way to get it in front of the customers more frequently, so they can tell you, yes, this is the direction we wanted to go, or no, it's not the direction we wanted to go. You can give them parts of their solution along the way, rather than having to wait for the full delivered application at the end. Much faster and typically more well received. A couple other development models is important to, well, they're not really development models. They're related to the development of something, and that is the idea of outsourcing software as a service, and we've already spoken about open source. Those are other ways for you to get the capabilities you're trying to deliver besides going and developing them yourself, but we've already covered those, so we're not going to spend much time on them here. The last thing I want to talk about here is this idea of sourcing. I mentioned it earlier in one of the other slides, I believe, but where do you get your software? If you're not going to, well, it's not the question if you're not going to, it's a question of how do you decide whether to build or to buy something. So how do you source this piece of software? How do you source your application or your business process? How do you source this information system? Do you build it or do you buy it? And there are definite pros and cons to both sides of the house. If you build it, you have a great deal of control over what you build. But at the end of the day, the negative is you're responsible for that. If it's broken, you're the one that has to fix it. And if the skills are no longer in your organization, there's nobody else you can give it to because you're the one that built it. If you buy it, you're kind of expecting somebody else to do the quality control of that application. But in many cases, they're also going to design it to meet the needs of lots of different customers, not just you. And perhaps it doesn't actually do what you want it to do, and you're left having to try and make it configure configure it in a special way or edit it in some special way to meet your particular business needs. Lots of questions go into whether to build or to buy, but the important point I want to make here is that that is not a technical decision alone. It certainly involves the technical side of it, but is by far more of a management and organizational decision than it is a technical one. So that's a brief overview of the application or system development world and what it looks like, some things that organizations go through to try and identify the issues around obtaining new information systems, what they want them to do and how they want them to work. And we'll
Okay, so a while ago, no, when we end before we start our class, no, I just give you 5 questions to answers in this lesson. No, number 1 question is, how does building new system produce organizational change? Building a new information system is a form of planned organizational change. So per kinds of technology-enabled change are automation, rationalization of procedures, business process redesign, and paradigm shift, with far-reaching changes carrying the greatest risk and reward. So many organizations are using business process management to redesign workflows and business processes in the hope of achieving dramatic productivity breakthroughs. No? Now, business process management is also useful for promoting total quality management, Six Sigma, and other initiatives for incremental process improvements. Number 2 questions, what are the core activities in the system development process? The core activities in system development are system analysis, system designs, programming, testing, conversion, production, and the maintenance. Because system analysis is the study of analysis of problems of existing system and the identification of requirements for their solutions, showing how each technical and organizational component fit together. Number 3 question a while ago. So what are the principal methodologies for modeling and designing system? As computer science student, of course, each and everyone are very much familiar with different methodologies in designing and modeling the system. So the 2 principal methodologies for modeling and designing automation or designing information system are structured methodologies and the object-oriented development. So structured methodologies focus on modeling processes and data separately. So the data flow diagram is the principal tool for a structured analysis, and the structured chart is the principal tool for representing structured software design. So on the other hand, no, object-oriented development models a system as a collection of objects that combine processes and data. Object-oriented modeling is based on the concept of class and inheritance. Number 4 question, no? What are the alternative methods for building information system? The oldest method, of course, for building system is the system life cycle, no? Which requires that information system be developed in formal stages. No? The stages must proceed sequentially and have defined output. So each requires formal approval before the next stage can commence. So the system life cycle is useful for large projects that need formal specification and tight management control over each stage of system buildings, no? As, but it is very rigid and costly actually, no? Sorry. So prototyping consists of building an experimental system rapidly and inexpensively for end users to interact with and evaluate. So prototyping encourage end user involvement in systems development and iteration of design until specifications are captured accurately. So the rapid creation of prototypes can result in systems that have not been completely tested or documented, or that the technical inadequate for a production environment. So using a software package reduces the amount of design, programming, testing, installation, and maintenance work required to building a system. So application software packages are helpful if a firm does not have the internal information system staff or financial resources to custom develop a system. So to meet an organization's unique requirements, packages may require extensive modifications that can substantially raise development costs. So end user development is the development of information system by end users either alone or with minimal assistance from information system specialists. So end user developed system can be created rapidly and informally using fourth generation software tools. However, end users develop may create information systems that do not necessarily meet quality assurance standards and that are not easily controlled by traditional means. So outsourcing consists of using external vendor to build a firm's information system instead of the organization's internal information system staff. So outsourcing can save application, develop cost, or enable firms to develop application without an internal information system staff. However, firm risk losing control over their information system and becoming too dependent on external vendors. So outsourcing also entails hidden costs, especially when the work is sent offshore. Number 5 question is, what are the new approaches for system building in the digital firm era? Excuse. Companies are turning to rapid application design, right? No, joint application design, agile development, and reusable software components to accelerate the system development process. So, rapid application development uses object-oriented software, visual programming, prototyping, and fourth generation tools for very rapid creation of systems. So, on the other hand, no, agile development breaks a large project into a series of small subjects that are completed in short periods of time. Excuse. Using iteration and continuous feedback. So component-based development expedites application development by grouping objects into suites of software components that can be combined to create large-scale business applications. So at present, web services provide a common set of standards that enable organizations to link their system regardless of their technology platform through a standard plug-and-play architecture. So I think that's it for our topic about building information system.